Hi, a very good morning. Today in this video I am going to present my project Microwave Oven Simulator using picsimlab PIC16F877A. So this is Sheikh Nazima Anjum from Electronics and Communication Department. Table of contents. So in this table of contents we can see aim, what is microwave oven, project requirements, embedded systems, microcontroller and microprocessor, overview of PIC16F877A, CLCD, matrix, keypad, MKP, ISR, timer and project implementation demo. So these are the table of contents which we are going to see in this video. Aim. Here our aim is to develop a microcontroller for a microwave oven. So what is a microwave oven? Microwave oven is used to heat the food using microwaves, which is from electromagnetic waves. So there are several modes in various microwave oven. So the modes are micro mode, grill mode, convection mode and the start mode. So first one is the micro mode. This mode is used to cook food in a traditional way. It uses a maximum power of 900 watts. In this, the maximum time that you are set for cooking is the 60 minutes. So in the grill mode, this mode is used to cook the meat and bread. It works as the micro mode, but the purpose is to cook meat and bread. User can set time as per the cooking time. And the third one is the convection mode. So in this mode, user can set the oven to preheat for a particular temperature and it takes 3 minutes to preheat the oven. After preheating is done, then the user can set the time as per the requirements. So the project requirements are different modes of microwave oven, setting temperature levels for each modes, setting timer for each modes, pausing the process in between as per the user requirement, displaying each function during each modes like micro, read, convection and stop, alert message or buzzer at the end of each program, alert message while opening the door while the program is running, also making the motor to run during each mode as per the above requirements. So firstly let's see what is the embedded systems. So embedded system is a combination of any hardware and software which is intended to do a specific task. So a general purpose system GPS is used to perform a large number of tasks, whereas embedded system ES is used to perform a specific task. So there are different types of embedded systems: standalone system, real-time system and networked system. Mobile system, standalone system, so slave system. These systems are not intelligent even though these are embedded systems. So this system cannot take action by their own. Example, microwave oven. Independent system. These system can take action by their own. Example, Google car or driverless car. And the second one is the real-time systems. These systems are time-bound system which will take action on a specified time. Failures in the system are not acceptable. First one is the hard real-time, firm real-time, soft real-time. And the example for the real-time system is the airbag system. And standalone system and real-time systems are completely different. Like here, the third one is the networked system, the system which are connected to a network. For example, home security system. When we take the example of a home security system, all the security in the home is connected to a network. And the fourth one is the mobile system. The system which are movable are called as the mobile system. For example, robots. And how to choose the embedded systems? So low power consumption, cost efficiency, efficient use of processing, power reliability. So these are the main concepts which we have to consider while choosing the embedded system. And the next thing is the microcontroller and microprocessor. So an integrated circuit which is capable of being programmed to perform a specified task. It has a design restrictions such as memory size, input output capabilities, peripheral functions, etc. So choose a microcontroller based on applications, perform, price, availability of tools and special. So let's see the block diagram. Microcontroller versus microprocessor. So here we can see the microcontroller and the microprocessor block diagram. The microcontroller is connected to the CPU, and this is the overview of the PIC 16F877A. So this is the pin diagram. So it can operate up to 20 megahertz frequency. There are three timers present over here: timer 0, timer 1 and timer 2. Timer 0 is an 8-bit timer. Timer 1 is an 16-bit timer. Timer 2 is also of 8-bit. It has 8-bit ADC module. It has a total. So this is the syncing and sourcing circuit. Here left side is the syncing and sourcing. Next is CLCD. CLCD is the character liquid crystal display. In picsimlab there are two types of display: 16 into 2 display, 16 into 4 display, 16 into 4 characters. So it displays the ASCII character and some special characters. It is mostly commonly used display. Two types of communication modes are present over here: 4-bit mode and the 8-bit mode. Next, tactile switch. So tactile switch is a switch whose operation is perceptible by touch. So this switch used to select the mode of operation and to enter the temperature and to enter the time into our project. So this switch will produce a bouncing effect when the switch is on. Next, MKP, matrix keypad. This is a keypad in which number of tactile switches are connected in a row and column concept. This is used when more number of user inputs are required and still want to save some controller input and output lines. These keypads are most commonly used in telephones. Next, interrupts. An interrupt is a communication process set up in a microprocessor or a microcontroller, in which an internal or external device requests the MPU or MCU to stop the processing. Then the MPU or MCU acknowledges the request and attends to the request, goes back to the processing where it got interrupted. So polling, it is a process where the computer or controlling device waits for an external device to check the readiness or state after with low. Next, the classification of the interrupt. Interrupts are classified into hardware, software, and maskable and non-maskable. Hardware interrupts are caused by external signal, software or by special instruction. Maskable interrupts can be delayed or rejected, and non-maskable can be delayed or rejected, cannot be delayed or rejected. So next, vectored and non-vectored are the subcategories. Based on the vector location, it is vectored. When it is routine needs supplied externally by the device, then it is known as a non-vectored. And ISR. So ISR is the interrupt service routine. An ISR is the software routine that hardware invokes in response to an interrupt. ISR attends to the request of an interrupting source by clearing the interrupt flag and should save register contents that may be affected by the code in the ISR. It must be terminated with the instruction read type. So when an interrupt occurs. Next, timers. So timer is an important application in any embedded system, which is a default peripheral which maintains the timing of an operation in sync with a system clock or an external clock. It has many applications such as measuring time and generating delays and etc. Next, the time or a counter is a software designed to count the time intervals between the events. Resolution, which is also called register width, 8 or 16 bit etc. So tie is referred as the change from one number to the another number. It may be up count or down count. Quantum, which depends on the system clock setting, is a measure of time which is responsible for the tick. Scaling may be pre-scalar or post-scalar. So now let's go to the dem. So here, when the microwave oven turns on, this is the pin. When the microwave oven turns on, you can see that now when you turn on, it shows the 4 modes. The first one, micro, grill, convection and start. So first you have to press the key 1 to start the micro mode, and then first step is displaying the power. It shows the power which is used in this. So here we are using 900 watts, and the second step in the micro mode is getting the time input from the users. So we will get some time from the users. So here I have given the time 1 minute and 23 seconds. So we have got. So now the third step in the micro mode control is time turns on. So the fourth step is when the time is up, so it reaches to 00, the fan stops. Here the fan stops and CLCD displays the time. Next it go back to the cook. So when you want to start the grill, you have to press the key 2. the first step is getting the time input from the users. So as usual, we will get the time from the input from the user. Then the grill mode will turn on. Next, the getting time from the input from the user. So and the second step in the grill mode is timer turns on and the time decreases. So when the time is up, like when the time comes to 00, the fan stops and CLCD displays the time and it goes back to the cooking mode. And when you press the key 3, so the first step in convection mode and the second step in the convection mode is preheating for 180 seconds with decrements 180 to 0. And the third step is getting the input from the user. After this step, the same process continues, like press 1, 2, 3 and 4. So after that, when you press the key 4, so first step is decrementing from 30 seconds. It decreases from the 30 seconds. So when key is 4 is pressed, time increases by the 30 seconds. And when the time is reaches to 00, the fan automatically stops and the CLCD displays the time. So when the door is open, the CLCD displays this message: the door is open, please close it. So now let's go into the demo. So here firstly we have power on our microwave oven and we can observe the 4 modes displaying over in CLCD: micro, grill, convection and the start. So these are the 4 modes which we can observe in our microwave oven. So when you want to start these modes, first we have to press those keys. For micro we have to press the 1, for grill we have to press the 2, for convection we have to press the 3, and for the start we have to press the 4. So now let's see this. So when I firstly press the 1, this micro will takes the step. So it take the input from the user and it runs the process and heat up the started with from 900 watts. Then this fan will turn on. Here we can observe a fan. This fan will turn on. So after turning on this fan, we can see the process. Now I have pressed 1 here, so you can see the whole process. Like I am giving the input time here. So that's the 23 I have given the time here. So the timer is getting start now. Look, you can see the timer is getting ready. Here I have set the timer from the user. So now mode 1, this is in the key 1, this is the mode 1. So now you can observe here the fan is rotating, here the fan is running. Here you can see that the fan is running. The process is going on here. So now this fan will turn off when it reaches to the 00. When this time reaches to the 00, now here it is 14, 13, 12. So likewise it decreases by 1 second. So after that the fan will get off. Now for the mode 2, I am here selecting the key 2. I am here pressing the key. So again this whole process will get run, like the fan will go. So here when it comes to 00, it will go through a time up and it goes back to the first stage. So it goes back to the first screen and it shows our 4 modes again, like micro, grill, convection and the start. So to start the step 2, to start the grill mode to on, we have to press the second key. Here I press the key 2 and I am giving the time again. So the fan is running. You can see here the fan is rotating. So when time is up, again it goes back to the first. So again here you can see micro, grill, convection and start, the 4 modes. So like this continuously, when the last step is over, it goes back to the first step. It shows the 4 modes again. Here you can see in this, it's showing the 4 steps again clearly. The fan has offed. Now I am pressing the key 3 and I set here the temperature. So the third mode is the preheated. So the oven have to get heated for the meat and the bread to cook the items like meat and the bread. For that, the oven will have to get the preheated. So it is in the preheating process. Look, we can see here. I have set the time. It's in the preheating process. Now you can observe that the fan is getting revolved. While the fan is revolving, when the time is come to 00, the whole process stops. Again, you can observe the four modes displayed on your screen: micro, grill, convection, and the start. So when the time comes to 00, the fan automatically stops. And now I am going to press the key 4 to start the process. Start. To start the mode start. So I'll again, when I press the key 4, it goes to the first mode. Like, see here, I'm going to press this key 4. So here I have given the time from the input, and now the fan turns on. The fan is getting revolved, and you can see here the time. So when you want to pause or stop, so you can press the keys 4, 5 and 6. So we have given all this information in the code, like at which key it is, which mode, like at which key it have to start, at which key by pressing the which key it have to stop. So we all have included all those things in the code. So when we dump this code into this, so this will work simultaneously. So actually embedded system is the combination of our hardware and software, right? So look, here we can see the fan is getting revolved. Here you can observe clearly the time is getting decreased. So when time comes to 00, automatically the fan will shut out. Here we can see it's 4, 3, 2 and 1. So here the time is up. So again it goes back to the micro, grill, convection and start. This is the overall view of my project microwave oven. So here we have observed the 4 modes: micro, grill and convection and start. This project really gives me a hands-on experience about microcontrollers, embedded systems, and this getting this opportunity to do an internship in Emertxe is really means a lot. Like, I have learned a lot in this journey. Like, I have gained hands-on experience about microcontrollers, and I have got a lot of knowledge about C. So this project really helps me a lot to learn the things about the microcontrollers and the embedded systems. So I really prefer you to do this internship. This is very helpful, and thank you so much. Thank you for your valuable time which you have spent to see this video. Hope you all guys like this video. Thank you.